Today's lecture is on remainder theorem and the factor theorem. Starting with the remainder theorem, remainder theorem is that when a polynomial px, this polynomial can be of any degree. When the polynomial px is divided by x minus a. So this is a polynomial, linear polynomial. So divisor is a linear polynomial. When a polynomial px is divided by x minus a, the remainder is given by pa. So from the linear divisor, you find the value of x by equating that thing to 0 and use this value of x here in the dividend, we get the remainder. So the remainder is given by pa. Remainder is pa, the value of pa. This value of pa we are obtaining by using the value of x, by finding the value of x from the divisor and substituting that value in the dividend. So this is how you can find the remainder. Let us for an example. Find the remainder when x cube minus 3x is divided by x plus 3. So this remainder you can find by using the long division, but here I'm using the remainder theorem. So what is the technique for find the remainder? Yes, make sure that it is linear divisor. X plus 3 is linear. This is the basic condition for the remainder theorem, that for the remainder theorem, the divisor has to be a linear. So x plus 3 is there. So px is x cube minus 3x plus 4, which is the dividend. X plus 3 is the divisor. By equating that divisor to 0, we get the value of x equals to minus 3. By using the value of x equals to minus 3 here, I can get the value, and this value will be the remainder when x cube minus 3x plus 4 is divided by x uh, plus 3. So minus 27 plus 9 plus 4, and simplification gives you minus 14. This minus 14 is the remainder. When you divide one polynomial, which is x minus x plus 4 by x plus 3. So this is the remainder. So this remainder theorem can be written in the extended form. So here, next I'm writing the extended form of the remainder theorem. So extended form. Extended form of the remainder theorem. So what is the extended form? When a polynomial px is divided by, say, ax minus b. Again, this is linear, but there's some coefficient for x. In the previous case, the coefficient of x was 1. When px is divided by ax minus b, the remainder is given by p b over a. The same approach from ax minus b, find the value of x by equating that thing to 0, and then using this value uh, here in the dividend, we get the remainder. So the remainder is given by p b over a. Example, find the remainder when x cubed minus 3x plus 4 is divided by 2x plus 3. Again, the divisor is linear and the coefficient of x is 2. So from 2x plus 3, you find the value of x equals to minus 3 over 2. This value, when we use here in the dividend, we get the remainder. So here, the px, the polynomial given is px is x cubed minus 3x plus 4. The divisor is 2x plus 3. X equals to minus 3 over 2 when we equate that thing to 0. P minus 3 over 2 is minus 3 over 2 whole cube minus 3 into minus 3 over 2 plus 4 and then minus 27 over 8 plus 9 over 2 plus 4 and this is equal to 41 over 8. So the value of minus 3 over 2 p minus 3 over 2 is 5 whole 1 over 8 and this is the remainder. This is the remainder for this problem. Now, what is the proof of the remainder theorem? Proof is very simple and interesting. Uh, Remainder theorem, the proof. So the theorem was when px is divided by x minus a means a divisor which is linear polynomial, basic condition for the remainder theorem, then prove that remainder is PA. The same, find the value of x from here and using the dividend. So what is the proof? Proof is simple. So in this case, dividend is px and divisor is x minus a. I'm giving the proof. Using the identity that dividend is identical to divisor multiplied by quotient plus remainder. So Px is the dividend, divisor is x minus a, quotient can be any quotient and remainder unknown. So, and yes, remainder must be a constant because the divisor is linear. We have this basic knowledge. Next, this is the identity. So what is the definition of the identity? Identity is an equation which is true for all values of x. So identity is something which is true for all values of x. So this is identity and this must be true for all values of x. In particular, it is true for x equals to a. So when you put x equals to, say, see what is happening here by putting, so this idea I'm getting right from here. So PA is equals to a minus a into some quotient plus remainder, which is required. So PA is equals to, obviously, this is 0 plus R. So this is R. And this is the remainder theorem that the remainder is given by R is the remainder. So remainder is PA. So when you put the value of x from the divisor here in the dividend, we get the, so this is the proof of the remainder theorem. Next, another example. Find the remainder when, find the remainder when x cube minus x square minus 5x minus 3 is divided by x plus 1. So solution to this. So the solution is that px is x cubed minus x squared minus 5x minus 3. The divisor is x plus 1. From here to find the value of x, use it here, minus 1. So minus 1, 3 minus 1 square minus 5 into minus 1 minus 3. This is minus 1 plus 5 minus 3, which is minus 5 plus 3, yes, 0. So the remainder is 0. So if the remainder is 0, we can use another term. So the divisor was x, this was the divisor. So x, this was the divisor, and as when the divisor, when the remainder is 0, we can say, so here this case, we can say that x plus 1 is the divisor. You can use the term is a factor of, is a factor of x cubed minus x squared minus 5x minus 3, because the remainder is 0. So I can give the idea why I'm writing this statement. Simply bring in mind the numbers. When you divide 8 by 2, 2 4 times is 8. The remainder is coming as 0. Yes, 2 is a factor. We use the term factor when the remainder is 0. This is the remainder is 0. So 2, we know that 2 is a factor of 8. So 2 is a factor of 8. So keep in mind this basic information that for the factor, for the if the remainder is 0, we use the term factor. Next is the factor theorem. Next is the factor theorem. The factor theorem is let px be a polynomial. Let px be a polynomial. If px is a polynomial, I'm writing two statements. I'm writing two statements. Carefully observe these two statements. The first statement is that if x minus a is a factor of px. So from the previous discussion, if it is a factor of px, then the remainder must be 0. And the remainder means pa must be equals to 0, means the remainder is equals to 0. So next I'm writing the converse of this statement in the next line, and that would be the, so if x minus a factor, the remainder is 0. If PA, if for this polynomial which is given PA, if PA is equals to 0, if PA equals to 0, if PA equals to 0, then I can write a statement that, so x minus a is a factor of px. This second statement is called factor theorem. This is basically the converse of the first statement. So this is the factor theorem. If x minus a, if pa is equals to, if pa equals to 0, 0, then x minus a is a factor of px. Here, I'm using the value of x is equals to a, and if x is equals to a, then from here, x minus a is a factor. I can write the statement that x minus a is a factor of px. So example, find a linear factor of, find a linear factor of x cube minus x square minus 5x minus 3 solution. So this is the expression, and for this I'm looking for the linear factor, and here I'll be using this B statement. I'll try to find a value of x for which the answer of this expression is 0, because if the answer of this expression is 0, then I can write this statement that x minus a is a factor of px. So here I use the uh, hit and trial method or trial error method. So hit and trial method is that try the number. So first we label this as px. Px is x cube minus x square minus 5x minus 3. We'll try to find a number for which the answer is 0, and then I can write this statement. So let us try x equals to 1. So p1 is coming as 1 minus 1 minus 5 minus 3. This is 1 minus 9 equals to minus 8, and this is not equal to, so reject this x is equal to x equals to 1. Next is x equals to, just try. First I tried this, then I'm trying x equals to minus 1 here, and let's check what is the answer here coming. So minus 1 cube minus minus 1 square minus 5 into minus 1 minus 3, I'm using it here. So this is minus 1 plus 5 minus 3, this 5 minus 5, yes. So p minus 1 is coming as 0. This is 0 means the remainder is 0. So the remainder is 0. The value which I tried was x is equals to x equals to minus 1. So as for x equals to minus 1, the remainder is 0. So I can use as for x equals to minus 1, the remainder is 0. So by factor theorem, so this is B part, the B definition. By factor theorem, from here, I can write a statement that x plus 1, because from x equals to 1, you can get the value x equals to minus 1, which I tried here. So x plus 1 is, obviously this is a linear factor of this x cube minus x square minus 5x minus 3. This is the factor theorem. So factor theorem, in the factor theorem, we try to find a number. So we use the basically we use the factor theorem to find a linear factor, and yes, the linear factor is there. The linear factor is there, and here the hit and trial method is involved. So I tried first 1 and then minus 1. So in the next lecture, I'll give the techniques how to shortlist the numbers, how to shortlist the number for which the answer for this polynomial, or of any polynomial px, can be 0. Okay, this is all about the basic introduction of the remainder theorem and the factor theorem. If you like this video, subscribe to my channel and click bell icon for more videos. Thank you.